Hi, and welcome to Module 15 of Lecture 1 of this course. Now, having done a little bit of math to give us a sense of the underlying foundations for the stats, we're going to get into some descriptive statistics here. Now, the very first step when you start any kind of empirical analysis is to get to know your data. Right? Often people tell you to just plot it, look at it, see what it looks like, look at the ranges of the variables, look at the variation of the variables. In general, before you start thinking about how two different variables vary together to try to assess causality, you want to see how each variable varies by itself. These are descriptive statistics, which we're trying to understand how our sample, right, what it looks like, and how it informs us about what each individual population looked like with respect to each individual variable on its own before we do any kind of covariation or correlations. Which kind of descriptive statistics you use will depend on your level of measurement, which is a large reason why we went through levels of measurement previously. So how might we summarize our data in a way that can give us insight into what it looks like? In this module, we're going to discuss central tendencies, sort of averages. In the next module, we'll discuss variation and variance. So there are several different ways that people typically summarize data in terms of their central tendencies. The first is the mode. The mode is just the most common score in your data set. So if, for instance, you had a nominal variable for direction and you had 10 people and 5 said east and 3 said west and 2 said north, and no one said south, then the mode would be east. I totally forgot what I just said, which is possible. The mode is the one that occurs most commonly, the value that occurs most often. The median is the middle score. It's obtained by putting all the different scores in a row and seeing which one occurs from in the middle case. So for instance, and if you have an even number, it's the average of the two middles. The mean is the sum of all scores divided by the number of scores. So the mean is the arithmetic average you've probably seen many times before. You add up all the elements and divide by the total number of elements. That's the mean. You use each of these central tendency measures differently based on the kind of data you have. So for nominal or categorical variables that have no order at all, the only thing you can use is the mode. Right? So these nominal variables can be described by their frequency only. So we can ask, okay, here's a different religion question from before. You have here 5 different categories, and in the second column here you have the number of cases in each category out of the total, and in the last column you have the percentage of the total that falls into each category. The mode is really the only suitable descriptive statistic here, and the most frequent category is here, Protestant, with over half the population in that category. Now you don't have to have a majority to be the mode, you just have to have the highest frequency, the most common value, in this case is Protestant. Again, because it's nominal, the rank and quantitative differences between categories means nothing, so all we can really do is say which of the categories occurs most often. So we use the mode to measure that. But even then, the mode is useful information, right? If I ask you, what does my data look like for this religion variable? You can say, well, the most common one is Protestant. I say, okay, thanks. I learned something about what my data look like. Okay, for ordinal level variables, we can do two things. We can still use the mode if we want to, because these are still categorical, and we can still get useful information out of which category is the most common. But now, because it's an order, we can also use the median. So what we do is lay the data out from lowest to highest in the order of the variable. And the median is the middle value. Now, important to note, and a thing people often make mistakes on, is it's not the middle of the possible values. So if your thing can take low, medium, and high, the median is not always middle, right? So if I have values that could be low, medium, or high for some particular question, and there are 100 people I've asked that question to, and 52 say low, and 30 say medium, and 52 low, 30 medium, and 18 say high, the median value is not medium, it's low, because the middle person of the 100, actually the middle 2 people in the 100, both said low. If that's not clear, it's reasonable. So take a moment, go back, look at that again. You can write out all the values from low to high. So the first 52 in that example have low. Then the next 30 have medium, and the last 18 have high. So when you start from the median, you go to the middle people in that ordered list. In that case, both middle people, number 50 and 51, are both low. So the median is low. So that's to keep in mind, but it tells you sort of what the middle person has, the median person. We use medians a lot in political science because of things called the median voter theorem, which is a way of understanding who is sort of pivotal in elections, majority rule elections. Sometimes you also don't want just the middle person, you want the whole range that's between the 25% person and the 75% person. That's called the interquartile range, or IQR, and this is just the value at the value of the 75 percentile marker minus the value of the 25 percentile marker. That works better when you have sort of numbers rather than sort of in this case medium minus low. But still, you could tell people that it's median minus low is the range between 25 and 75%, which is useful information as well. Okay. But again, the median here is very useful for ordinal variables because you can order them and pick out what the middle person has done, has chosen, has answered the question, whatever, that value for the middle person. And here the middle person is sort of half the people are more extreme in one direction and half the people are more extreme in the other direction. So in the sense, the middle person exhibits some kind of central tendency, sort of an average behavior. Okay. The one you're more familiar with probably is what to do with interval ratio variables, which are just numbers. And for those, we can describe moments of the variable. These moments, the first moment describes the central tendency of a variable. Higher moments describe distributions around the central tendency. The first moment is the mean. The mean you've seen before, it's just x bar is one way of writing it for a sample. X bar means the mean of x. Here x is a vector, and here's why we went to the vectors before. X is a vector, it's a list of values. Each value has a subscript I, meaning it's either the first element or the second element or the third element. In general, these are data points. So it's the x corresponding to the first data point, the x corresponding to the second data point, and so on down to the nth data point. So each one of these, you take each element in that vector x, and you add them up together to form the sum of x, and this capital sigma over here means sum. We often write it with saying we go from 1 to n. Sometimes we'll drop the 1 to n and just write the sum by itself, where it's implied you sum over all the values of x to save space, but they mean the same thing. But in general, if you see a capital sigma like this, it means add all the elements that come after it. And usually they'll have a subscript, so you add them all from the beginning of that series, from, in this case, from 1 to the end of that series, in which case is n. So you add all the x's from 1 to n, which is basically adding all the values of your independent variable for all the elements in your data set, and if it's a survey, for all the people in your data set. That's the sum of all the different values. Then you divide by the number of data points, in this case is n, to give you the average value of that variable, x. That's the mean. That describes the average value, which is another way of getting at the central tendency of a variable. The mean has a bunch of nice properties that make it really useful. One is called the zero-sum property, which is to say if we take deviations of each data point from the mean, and this thing in parentheses is a deviation. So here's the mean. Xi minus the mean means I see how much bigger or smaller this particular data point is from the mean of that variable. When it's bigger, this is a positive number, and we're deviating upward from the mean. And when this is smaller than the mean, this is negative, and we deviate downward. If you add all deviations from the mean, you get 0. Because on average, there's no deviation from the mean, because that's the definition of the mean. It's the thing that produces the sort of average value, and has as many things higher, the sum of as many things higher as the sum is of many things lower. So that's the mean. possibly more importantly for our purposes, is the least squares property, which is if you take these deviations and you square them and you add them all up, that sum of squares is going to be less than the same sum of squares with any other number put here in place of the mean. So in some senses, this mean minimizes the sum of squares from each of our data points. That's going to end up being useful. Okay. So because of this, the mean is what we call the expected value. What does that mean? The expected value of a variable is really our first pass guess at what that variable what the value of the variable would be if someone just asked us off the top of our heads. So if you want to predict how much a person would make an income at random, right, the mean of the population is your best guess. You will surely be wrong. But if you do this an infinite number of times, no other guess you could have said would be closer than the mean. In a sense, the mean is our first pass model, right? With more information about how individuals vary in their incomes and what affects their variations, you can do better than the mean. But if all you have is nothing else, no other information about how people form incomes or obtain incomes, the mean is a good first guess. Because it's the expected value of this variable, x, in the population, or in this case in the sample. Okay. That said, the mean has some issues. So here are income data from 2012. And imagine a research question here is to know how much money the average 25-year-old makes. So we take a sample of 10 25-year-olds at random. And we go through this, and there's variation, of course, but the mean seems like it might be informative so far. And we get to the bottom. LeBron James, right? And that income is way more than everyone else's income. So the question then is the mean still useful? Well, let's see what the mean actually tells us. The mean with LeBron James, the mean is over $1 million a person. The mean, an income mean that's over $1 million a person for 25-year-olds is not going to be very informative about the average person's income. And in fact, if you remove the outlier of LeBron James in this case, you get 21,000. So a huge difference. This is the reason you'll often see mean incomes across populations skewed highly to the right, skewed highly large, because certain incomes of certain individuals are just way more than everyone else's and pull the entire average much higher. So in cases when they're extreme outliers, you have to be careful using the mean, because they can pull them either much lower or much higher based on the direction of the outlier. Now, the median doesn't respond nearly so strongly. With LeBron, the median is 23,000. Without LeBron, the median is 21,000. So sometimes the median can be really useful for assessing the central tendency of a group, of a sample, of a variable, when you have strong outliers in that sample that might skew the mean too much in one or the other direction. So the lesson really is always look at your data. Look at the range and check out the outliers up front, and that'll help you figure out if you want to use something like the mean or switch to something like the median. Okay. So that's it for central tendencies. We'll move on to variances and dispersion in the next and second to last module in this lecture.